Hello, and welcome to this NPTEL course on the Foundations of Continuum Mechanics. I'm Gaurav Bhutani, a faculty member at IIT Mandi. Standing here in the mountains, surrounded by snowfields and flowing streams, I'm reminded of something beautiful about continuum mechanics. The same equations that describe the flow of snow in an avalanche also describe the flow of water in a river, the motion of air around an aircraft, and even the vibrations of a structure, or the deformation of the slope on a mountain when it slides. This universality is what makes continuum mechanics so powerful and so interesting. Let me take you through this journey. This course builds the mathematical and the physical foundations of continuum mechanics, which is the language behind solid mechanics, fluid mechanics, and almost every subject that deals with advanced mechanics, such as the fields of computational fluid dynamics and computer-aided engineering. We will begin this course with a foundational mathematics of tensors. Tensors form the language of continuum mechanics. Just like vectors form the language of basic physics, so do tensors form the language of this advanced field of continuum mechanics. We will go deep into tensors, first by defining tensors and then defining various operations related to tensors. Just like the snow behind me on the slope can deform, flow, or compress under loading, we will then learn the various objects which are used to quantify this deformation. We'll talk about stresses and we'll talk about strains which are a part of kinematics so that we can link them through the balance laws which will then be used to solve the equations of mechanics. After building up on the conservation laws, we'll talk about constitutive models, which are material-specific properties which allow us to link the stresses to strains or rate of strains. And finally, we'll apply these ideas to real problems. This is a 12-week course. Each week will include 4 focused lecture videos spanning 30 minutes each. This will be followed by a tutorial that will discuss problem-solving strategies. We'll be providing 1 assignment per week to you to reinforce the key ideas, and we'll also provide our lecture notes in the PDF form for you to recap or revise the material. We will go slowly and carefully, especially with tensors. With practice, something that may initially feel abstract will become a second nature. My only expectations from you are simple. Just enjoy the subject. If you enjoy it, you'll understand it deeply. Focus on the ideas because equations, although they're important, but the intuition behind them matters even more. The intuition will stay with you, and this is one of the major learning outcomes of this course on the foundations of continuum mechanics. Another important thing that you have to focus on is to solve problems regularly. This is the key to becoming comfortable with the mathematics and physics of the course. Continuum mechanics can feel challenging, but it becomes beautifully simple when the foundations are clear. By the end of this course, you'll be ready for subjects like computational fluid dynamics, elasticity, finite elements, turbulence, and so on. Thank you for joining this journey with me. Just like the landscapes around us are shaped by the forces acting continuously over space and time, continuum mechanics helps us understand and model the physical world around us, from the flows of snow to the skyscrapers around us. I look forward to learning with you. And please remember, this course is all about the mathematical and the physical foundations of the subject of continuum mechanics. See you in the first lecture.